the thermodynamics, and there also I have given you the statement of thermodynamics in different forms. So today we are going for its mathematical expression. Okay. Mathematical formulation of first law of thermodynamics. So let us consider a system whose internal energy is Q1. If the system is supplied with Q amount of heat, the internal energy of the system will become U1 plus Q. Now, if work W is also done on the system, the final energy is U2. So what we can write now? Thus, Q2 is equal to U1 plus Q plus W, or U2 minus U1 becomes Q plus W, or delta U equal to Q plus W. This is the mathematical formulation of first law of thermodynamics.
তোমার অ্যালার্মটা বাজে না?
In this statement, Q is the amount of heat absorbed and W is the amount of work done on the system. Please remember, on the system. So it is always plus. If, so right now we are equation 1. No, this is equation 1 and this is equation 2. If Q is the amount of heat absorbed and W is the amount of work done by the system, then equation 2 can be written as delta U is equal to U minus W, because we know work done on the system is plus and done by the system is minus. So both of them, this and this, are the mathematical expression or formulation of the first law of thermodynamics. See, in different cases you'll find that this, when you try to apply this law in different conditions, what will happen? So application of first law, huh? One is free expansion. Free expansion means if you have kept a volume of gas in vacuum, okay, what is going to happen? Expansion of gas against zero pressure or expansion in vacuum is called free expansion. Right now, yeah. Work done in free expression. See, expansion means against done by the system. So it is called P external delta V. No, it will not be P external. P internal delta V because pressure inside is more. So it is expanded. See, in vacuum, what happened? In vacuum, there is no air. So if there is no air, then where from the P external to the air? In vacuum, P external is equal to 0. Therefore, P external delta V is also equal to 0. So what should I write now? Putting this condition in first law of thermodynamics. So what you can write here? Delta U equal to Q minus W, or you can write delta U equal to Q minus, we know is what? It's not P into delta V. W pressure is this. So what we can write now? Or delta U equal to Q 0 into delta V, or delta U equal to Q. In here, see, in this case, we know whatever amount of the heat is being supplied, this is being converted into internal energy. gas in pre-expansion the heat change of a system is equivalent to the internal energy change delta U. It is the heat supplied to the system is being converted into the internal energy of the system. Now we'll go for second is reversible isothermal change. See here. In isothermal condition, delta T is equal to 0. When delta T is equal to 0, then because you know internal energy depends upon temperature change, so delta U is equal to 0. Applying this condition on first law of thermodynamics, delta U is equal to U minus W, okay, or delta U is equal to Q into what? P into delta V no P into delta V or what you can write, we have already done that delta U is equal to delta U is equal to 0. So 0 is equal to Q minus W. Okay, I write like this. Q minus W or U is equal to W. But W is equal to what? But we know W is equal to P into delta V is equal to, that we have already calculated now, that it is 2.303 nRT log V2 by V1. So therefore Q is equal to 2.303 nRT log V2 by So what can you write here? In this condition, whatever amount of the heat is supplied is being confined to what? Thus, in this condition, the entire amount of heat supplied is converted into work. So reversible process.
So done.
Now, see, it is irreversible process. So irreversible process is what? We know W is equal to P into delta V. So therefore Q is equal to P into delta. Statement is same. You have to remember this for numericals. Finished? Hmm?
Yes, sir.
Hello.
Yes,
Okay.
sir.
Now we will go for adiabatic process. Adiabatic process. In an adiabatic process, no heat comes from outside to inside or inside heat can go out. So Q is equal to 0. Therefore, the first law of thermodynamics can be written as, see here, delta U is equal to Q minus W. So Q is equal to 0. So here what will happen now? Delta U is equal to minus W. In such cases, the internal energy of the system is used, is converted to work. So what I can write now here, that is the work done by the system will gradually decrease the internal energy of the system, as internal energy is directly proportional to heat. So the temperature of the system will also decrease. This equation which I have written, that delta U is equal to minus W, this is the equation consisting only of 2 letters. Okay, but such a wonderful discovery is being done on the basis of this, or invention, you cannot imagine. See, on this equation, our refrigerator or fridges work. the fridge is being made on the basis of this principle. Okay, in fridge, the expansion of the gas is being done inside the fridge in an insulated condition. In that case, what happens? As it is insulated, so heat from outside cannot come inside, and from inside it does not go outside. So what has happened now? In that case, as the expansion takes place, so when the expansion takes place, internal energy of the gas decreases. And as the internal energy of the gas decreases, temperature inside the fridge decreases. Okay, now we are going to introduce a new term called enthalpy. There is no clear-cut definition for enthalpy. Okay, so we write enthalpy is defined as the sum of internal energy. Okay, so right now here U and the product of pressure and volume. Is the sum of the internal energy and the product of pressure and volume. It is denoted by H. Okay, so what I can write now? Thus, H is equal to U PV.
আমার পুজো করতে করতে দেরি হয়ে গেলে আমিও দুধ খাই না তো একটা রুটি খাবে তুমি রেখেছো না চা দিয়ে রুটি খেয়ে ফেললাম
Change. So let a system has of volume V1 at pressure P1 has an enthalpy of H1 is raised to volume V2 pressure P2 and enthalpy H2. So this is equation 1. Thus, in initial state. H1 is equal to U1 plus P1. Wait. Has an internal energy of U1 and this. Similarly, you write raised to volume this P2 group and internal energy U2 and enthalpy of H2. This is equation H2 U2 plus P2.
Sir, done.
Okay. Should we write now here? Enthalpy is a state property. That is, the enthalpy change that is what I am writing here, delta H. Can be obtained by subtracting initial enthalpy, say it is H1, from final enthalpy H2. Therefore, delta H is equal to H2 minus H1. Because we know that there are two types of factors are there. One we call path dependent, second one we call state dependent. So enthalpy is state dependent. We cannot calculate all these things. So it doesn't depend upon the path or the method which you follow. Okay. So let me write here this equation 4. So I'll substitute these values. Right now here delta H is equal to U2 P2 V2 minus U1 E1 E1. Okay. So now we can write here U2 minus U1 plus P2 V2 E minus P1 V1. So I can write now here it is delta U plus delta PV. Okay. So therefore delta H is equal to this. It is written, it is a change of pressure and volume. Okay. So in this case, what can happen? Either pressure can change or volume can change. Huh? So let us see. So we'll now separate it. So I can expand it. See here. I can write or delta H is equal to delta U P into delta V or what? V into delta P. This I've expanded. Okay. So I can write now. See, when we carry out any experiment, I can change the pressure, but volume, I cannot change the volume of the container. Suppose you cook rice in a pressure cooker, you may cook more rice or can less rice, but the volume of the pressure cooker remains same or not? Okay. So we'll write here. Now at constant volume, delta V becomes equal to S. Wait. When you go for at constant pressure, because we are going for open system pressure always remains same. At constant pressure, delta P is equal to 0. And so equation 6 can be written as delta H is equal to delta U P into delta P. Dynamics. We know that W is equal to P into delta P. Work means P into delta P. This is 7. Therefore, equation 7 can also be written as delta H is equal to delta U plus W. According to first law of thermodynamics, delta U is equal to Q plus W. By comparing equation 8 and 9. It can be written that wait. The expansion is going on. No, sorry. Therefore, Q is equal to delta U plus W. Okay, now I'll write. Comparing equation equation 8 and 10. It can be written that, see, this and these are same. It can be written delta H is equal to Q. But what is the condition? When did you get this equation? Only at constant pressure. So we write here this. This is the condition. See, up to your level, thermodynamics is not difficult. And derivations are also very simple. Now say, here we have put the condition, we have kept it under constant volume. Sorry, constant pressure. But suppose if you take a system in which where we neither change the volume, nor do you change the pressure. In that case, what will happen? If the system is under constant pressure and constant volume, then the delta V becomes equal to 0. So in that case, what happens? Delta H is becomes delta U. So right. If the system is under constant volume. See, if the volume is constant, pressure is automatically constant. Then equation that is delta V is equal to 0. Then equation 7 can be written as, suppose it is equation 7. We know delta H is equal to delta U plus P into delta V 7. Okay. So what is the condition here now? Delta V is equal to 0. Therefore, delta H is equal to delta U. Okay. So now right here is 11. All right. But we know that delta H is equal to Q. Therefore, we can write here delta U is equal to UV. That's constant body. Relationship between delta H and delta U. So let us consider a reaction involving gases, means where both the reactants and products are gaseous. The reaction is carried out at constant pressure and constant volume. Sorry, constant temperature. Let VA be the total volume of the reactants and NR be the total number of moles of the reactants. VB is the total volume of the products and NP are the total number of moles of the products. You can write here from ideal gas equation we know PV is equal to nRT. Therefore, PVA is equal to NART. V is the volume and the number of moles. Okay? And PVB is equal to NBRT. So now we can write, therefore, P, this is the final and this is the initial. Products are always final. So PVB minus PVA is equal to what? NBRT minus NART. Or if I have taken the common, BB minus PA is equal to NB NART. Or what I can write, P delta V. See, number of moles of this and number of moles of this. So I'll get, so I can write here what? Delta N. G stands for gases. So we can write now here, substituting the value of P delta V in the following equation. We know delta H is equal to delta U plus P into delta V. Okay? What we can write now? We get delta H is equal to delta U delta N G R T. I don't know what will be the equation. It's a separate thing now, so I can write it here. 1, 2, 3. Okay. Then here we can write 4. It is 5. Then it is 6. So let us try to find out what is the relationship they have. See here. In this case, delta H can have 3 values. What is this? 1. So here I can write delta H is equal to delta E. When it is possible? When delta Ng is equal to 0. Example, say I have taken here H2G, I2G to HIG. These are all not imaginary reactions. See here. How do you know? See here. Delta Ng is what? Number of moles of product minus number of moles of reactants. So we know total number of moles of product minus total number of moles of reactant. See here. How many moles? 2. How many moles? 1 mole and 1 mole. So 1 plus 1. Okay? So it is equal to 0. So under this condition, delta H is equal to delta U.
Done.
Now second, is you find delta H is greater than delta U. When delta Ng is positive. Okay. Example. See, I have taken here PCl phosphorus pentachloride gaseous. If you heat it, you will get here now PCl3G and Cl2G. So under this condition, what is delta G? See here, product minus reactant. So it is 1 plus 1 minus 1 is equal to what? Therefore, delta Ng is 1. Or what you can write? Or greater than 0. So in this case, what will be the equation here? See here. In this case, equation is delta H is equal to delta U N G R 3. N G into this. See here. This. That is, if you add this much with internal energy, then only it is equal to delta H. So this delta H is bigger than delta U. These equations are important for your entrance as well as your board exam. They will give you numericals. Third, delta H is smaller than delta U. When delta Ng is negative or less than 0. See here. Example. This plus this. This is a very famous equation. Reverse process. See here. Delta Ng is what? 2 minus 1 plus 3. That is equal to what? Minus 2. So in this case, what is the value of delta H? Delta U minus 2 into R. Okay. Up to this much is enough for today.
Thank you, sir.
Okay. Welcome.